So this week in geometry, we are talking all about quadrilaterals. And before we get into the actual quadrilaterals, there's a few things we need to talk about to make sure we understand some of the things that we are going to use to define quadrilaterals, and those are lines. Now, we need to remember a few things about lines first, and that's that lines are straight, that is that they never curve, and that they go on forever in every direction. Being that when we draw a line, we have the arrows on both ends to show that even though we can't actually draw it or can't actually represent that it goes on entirely in those directions forever and ever and ever, we use the arrows to show that that's what we mean. And so on a plane, lines come in different ways that they can interact with each other. Sometimes the lines cross, and just generally lines that cross are called intersecting lines. And that's because in geometry, the term for crossing is actually properly called intersecting. You don't need to pause the video to write this down right now. We're going to go through 3 different types of lines, and then you can pause the video and write down all 3 at the same time. So if lines cross, they're called intersecting. If they happen to cross at right angles, we call them perpendicular. It's a special type of intersecting lines. Any other type of lines that cross are just called intersecting. If they happen to cross at right angles, represented by each of the 4 red boxes that we see here that denotes a right angle, those are called perpendicular. And if the lines truly will never at any point cross, then we call them parallel. And just like we use hash marks to indicate identical sides, how we use red squares or just squares in corners to represent right angles, we have arrows that we use to represent parallel lines. And so just like hash marks, they need to be the same number, the same color, the same size, etc. to represent that lines are parallel. So go ahead and pause the video now and write down, along with the images, the definitions of intersecting, perpendicular, parallel, and this description of what the arrows mean. Again, both the definitions and the images, and then come back when you're ready to move on. So now that we have reviewed those types of lines, we can go into talking about quadrilaterals. And so when we're talking about quadrilaterals, there's a few important things. You don't have to write these down because they'll come up later. First is that quadrilaterals, by definition, are polygons that have 4 sides. So anytime that you have a closed figure made of straight lines where there are no intersections except at endpoints, then we have what we call a quadrilateral. And so amongst quadrilaterals, just like we have amongst triangles, we have ways that we can classify those quadrilaterals based on both the number and types of parallel sides and the types of angles that they have. So first, we want to look for pairs of parallel sides. If there is no set of 2 edges for a quadrilateral that are parallel, then we just call it a quadrilateral. It has no special name. If, however, it has 1 pair of parallel sides, we call it a trapezoid, and that's the definition of a trapezoid. So I'm going to ask you to go ahead and pause the video here and write down both the definition of the trapezoid and the picture here, including the arrows that are here to indicate that these 2 sides are parallel, and then unpause the video when you're ready to move on. So I want to mention and draw your attention to the fact that in the image of the trapezoid, we have only the 1 set of arrows, which indicates that the sides are parallel. And although in this image it seems obvious that the other 2 sides aren't parallel, some of those sorts of distinctions are not things you can necessarily make just by looking at a picture. So unless the picture says drawn to scale, or angles are the same, or sides that look parallel are parallel, we can't assume that any set of sides is or isn't parallel. So that's what we have the arrows for. If a quadrilateral has more than 1 set of parallel sides, and since there are only 4 sides to a quadrilateral, it can only have up to 2 pairs of parallel sides. If it has 2, it's called a parallelogram. And take a look at the different types of arrows that we have here to represent parallel sides. Single black arrows for 1 set of sides, and double red arrows for the 2nd set of parallel sides. So go ahead, pause the video, draw the parallelogram image, including the sets of arrows that we have, and write down the definition of parallelograms, and unpause the video when you're ready to move on. So after we've established these sets of parallel sides, if we have just a plain quadrilateral with no sets of parallel sides, then that's it. That's what its classification is. If we have only 1 set of parallel sides to become a trapezoid, that's it also. That is what its classification is. But if we have a parallelogram with two pairs of parallel sides, we can actually potentially go deeper into classifying this quadrilateral. So, if it's a parallelogram, then we have a number of different ways that we can look at its side lengths and its angle types to determine what specific type of parallelogram it is. You don't have to pause the video after each one to write them down. I'll give you a chance and let you know at the end of the three types that we look at here when to pause the video and write these down. So, if we first look at side lengths and we find that all of the side lengths are the exact same length, then we have what's called a rhombus. And a rhombus is a parallelogram that has four sides of equal length. If we have four right angles in our parallelogram, we call that a rectangle. And so it's important to note that the definition of a rectangle is just that it has four right angles. And if we have a quadrilateral parallelogram that combines the characteristics of a rhombus and a rectangle, has four sides of equal length, and four right angles, we call it a square. So go ahead, pause the video now, write down the definitions of rhombus, rectangle, and square, being sure to include that it is a parallelogram with four sides of equal length, a parallelogram that has four right angles, a parallelogram with four equal sides and four right angles for a square, including the images that we have here with the hash marks, and then come back when you're ready to move on. So I want to mention something important about a rectangle now that you've written down all of these definitions. And notice that the definition of a rectangle is just that it's a parallelogram that has four right angles. One of the things that we know about rectangles, which is true and will always be true about rectangles, is that they have opposite sides of equal length. And we can see that because the hash marks are here on this one also. But it is not the definition of a rectangle that it has opposite sides of equal length. That is an important characteristic that is true of all rectangles. But if we're truly looking at what defines a rectangle, what makes a rectangle, then it is a parallelogram with four right angles. And so there's one last thing that we want to talk about and I'm going to ask you to write down, and that is the characteristics of all quadrilaterals. We already talked about before the fact that quadrilaterals each have four sides and four angles. And much like triangles, the quadrilaterals also have a certain number of degrees when you add up all of their angle measures that is characteristic of all quadrilaterals. So two things that make all quadrilaterals the same are that they have four sides and four angles, and that the sum of their angle measures is always 360 degrees no matter what type of quadrilateral you have. So go ahead, pause the video one last time, and write down these two things that are the characteristics of all quadrilaterals.